All right, it's 10:02 on my clock. We're gonna get started. All right. Welcome to another great green energy series. It's presented by Solar Oregon. My name is Edward Louie. I'll be your host and a presenter today. So a little bit about Solar Oregon. Solar Oregon is a nonprofit founded in 1979. This year makes it 46 years old. It grew from grassroots efforts to support clean energy and clean and renewable energy. And we're continuing that mission today by being a bold voice and trusted educational resource to empower all individuals and communities statewide to adopt solar energy. We offer many webinars and events throughout the year, including many solar plus storage webinars, which are like 101 webinar. We deep dive into specific topics through webinars like this green energy series. We do many in-person events, such as a solar winery tour, where we learn about the many farms in Oregon that have chosen to partner with solar installations to do agrivoltaic operations. In Oregon, we have quite a few of them, and so we tour some new ones each year. We also do an annual Go Zero home tour, and that's actually a in-person event coming up in October. Later in the webinar, I'll present a little bit more about the date and a little bit about more of that tour. We also do Solaris campaigns where we canvass neighborhoods and get multiple homes to go solar at the same time, and therefore reduce some of the soft cost of going solar and resulting in a lower cost to go solar for everyone involved. We also do many peer-to-peer education events, and you're encouraged to use the Q&A and the chat in this webinar to ask questions, and I've set it up so that you can also see other people's questions, and so hence supporting that peer-to-peer um, ethos. So again, my name is Edward Louie. During my day job, I work as a building energy efficiency research engineer at Pacific Northwest National Laboratory. PNNL is one of around 17 national laboratories that U.S. Department of Energy funds. You're encouraged to find me on LinkedIn. I post quite frequently on my LinkedIn, and some of my hobbies are not that different from what I do during my day job, which is I love testing energy efficiency technologies in my home and helping friends and family with their energy efficiency efforts. We already have a question about Solar Oregon. Do we cover wind power generation as well as solar? Solar Oregon does help with partner organizations that are more focused on wind power. Our organization is quite a bit more focused on solar. A little disclaimer is that the views in this presentation do not necessarily represent the specific position of PNNL, U.S. Department of Energy, or Solar Oregon. Best efforts have been made by me to convey facts and information accurately. However, you're always encouraged to do your own research and do your own calculation before making investment grade decisions. So, we're now diving into the meat and potato of this webinar, which is about portable and window heat pumps. There are many gems and wonderful products in these categories. Unfortunately, they're not that well advertised, and they're buried amongst pieces of equipment that can only do air conditioning, and hence why I think this webinar is useful and will help shine light into these gems of products that are hidden among the pile. And so we're going to begin by looking into what it is and how it works. We're going to look at the different form factors available, some of the pros and cons of each form factor. Then we're going to look at some spreadsheets, that compile the products on the market. Note they're not going to be complete spreadsheets, but they may cover 90, 80% of the products on the market. So, maybe a majority. Um, and during those spreadsheets, we'll look at kind of key specific specifications to look for. And as I said, these products are kind of buried among products that only do air conditioning. So we'll look at some industry terminologies and keywords to look for, or key specifications to look for. that will be able to reveal which ones can actually do both heating and cooling, hence be a full-fledged heat pump. And then we'll then look at evaluate maybe what are the target markets for these products, who should buy them, and then end with some summary and conclusions. So, what is it and how it works? They really are just a air conditioner, which, by the way, air conditioners are one-way heat pumps. They are heat pumps. They're removing heat from the indoor environment and putting it outside. Uh, and so these units that we're talking about is a unit that has a reversing valve. That red box there is showing what a real world in reversing valve looks like. And a reversing valve allows a one-way heat pump to become a two-way heat pump. So that you can change, uh, which side gets hot and which side gets cold. Um, and so you can imagine that like with that additional part that maybe costs the manufacturer $10 or $20 extra, um, that these units should not be that much extra. Um, and indeed, we'll look at products that really aren't that much extra compared to a one-way heat pump or an air conditioning only heat pump. And later I'll discuss why there are some products that are significantly more expensive. So form factors available. So in the upper uh, left corner, we have an example of what's called a saddlebag or a straddle window style form factor. Um, these fa form factors, we'll get into more, but one of the advantages is that, they allow the window to close quite a bit, like almost fully, and maintain the view through the window. So that's one advantage. And then the upper right-hand side, you have your traditional box style window uh, heat pump. And then in the lower left side, there are what's called portable air conditioner or portable heat pumps. And these are the ones that in this category are the ones that connect to the outside via ducts. And so I'm calling them portable style with ducts. The reason why we call them with ducts is because there's also this very small category, but hopefully it's a growing category, which are portable style um, air conditioners and heat pumps that are connected to the outdoor via a line set, so that the outdoor condenser is in a lightweight box that sits outside. So again, there's certainly some pros and cons to each of these form factors. And the straddle or saddlebag style window heat pumps, some of the pros is that you maintain that view through the window. The window is mostly closed, so you get some additional like envelope energy efficiency from having the window mostly closed. And this style form factor is where some of the highest performance models are available. Um, there are some cons to every form factor, and the cons in this form factor is that they're really only a good fit for hung style windows. Um, you need to have unobstructed space below the window. So many homes, especially smaller homes, have furniture underneath the window, and so that makes it challenging. Um, this form factor also needs the largest width of all the different categories. So your window needs to have a width of around 26 to 27 inches of free openings. So we're not talking about the window with the frame. Like we're talking about the sash when you open it and then the free opening. So that part needs to be 26, 27. So that means your window probably needs to be like 30 or 32 in the actual window width to achieve a 26 to 27 inch so what's called net free opening. Um, and these units are very heavy to install. And later we'll look at, product availability to the consumer market. And these products are currently not yet available to direct to consumer. And I think the weight of these products being 129 to 140 pounds is one of the main reasons why the manufacturers of this form factor is not currently interested in doing a direct to consumer sale, and they are the most expensive models. Where they because they're not direct to consumer, the prices are not quite available. But I have some estimates and some uh, maybe unofficial numbers that I can share to give you kind of rough estimate ballpark of what these window in the straddle style what they cost. And then we have the box in window form factor. Um, some of the pros is there are some significantly less expensive options in this style available to the consumer compared to the straddle or saddlebag style window heat pumps. But there are some cons. One is that this style form factor is really optimal for hung style windows, so your single and double hung windows. The view out the window is significantly more obstructed, and the window is open more, so your envelope efficiency is a bit more reduced. Um, Again, it's a little bit better than the straddle or saddleback style in terms of the net free opening that you need in order to fit this in. So smallest models in this category really only need 24 inches. Um, and then they're still kind of heavy to install. We'll look at some weights. They're typically around 50 to 60 pounds, but 50 to 60 pounds is over half the weight of the category above, which is why 50 to 60 pounds is about also the limit of, one person being able to safely install something. So hence why these ones, the less expensive options in this category, are available directly to consumer, whereas the ones in the category above are not. Um, then there's interesting category that we'll then look at, and we'll see that they're not quite available in the US market yet. But I've talked to the manufacturers and they are interested in bringing them to the US. And that's the portable air conditioning and portable heat pumps that connect to a outdoor condenser via a line set. And this line set is pre-made in the factory, so it's completely sealed and um, the consumer is not to mess with the line set. You just need to be careful when installing it so that you don't damage the line set. And that is one of the cons is that, the connection between the indoor portable unit and the outdoor condenser box that you put outside is connected by line set. So you need to be careful and gentle with that line set. There's very few market models available on the market, even globally. But because it's connected via line set, the window can be very closed. Um, and there's very little installation weight compared to the above units where, the indoor parts of the heat pump and the outdoor parts of the heat pump are on one box. This one, the outdoor unit is significantly less in weight, and you can fit them in more window types like sliders and casement windows, versus it's very difficult to practically get uh, the form factors above into sliders and casement windows. And then there's the portable air conditioning, portable heat pumps with that are connected to the outdoors via ducts, so that the heat exchange is done via ducts. Um, Again, this type of form factor, this one's quite common, um, and you can do more window types, so not just hung windows, but sliders and casements also. The duct diameter is such that you can have your window mostly closed, so you get some efficiency gains associated with that. Because the units are connecting to the window via ducts, you're not really having to carry any weight or up and over the windows, so the weight is for installing it is quite easy to manage. Um, they're a tiny bit noisier than the above options because um, like if you're able to for example, the saddlebag style window uh, heat pumps, the compressor is actually on the outside. So then the noise is outside your window and you close the window. That noise kind of goes away a little bit more. But with these portable heat pumps, the compressor and fan for the outdoor side is indoors. So again, there's going to be a little bit of more noise, but I mean, modern compressors are really good in terms of being quiet, and modern fans are very good at being pretty quiet. So they're not terrible. And then efficiency is generally a little bit less, but you'll see that, with modern engineering, they've been able to get the efficiency pretty comparable. Okay, we'll move on to the next slide. So, the saddle and box style window heat pumps, this is a spreadsheet that's kind of building out what products are available on the market. I said full list, and maybe I should, take that back and say that this is maybe a 95% list. I might have missed one or two. But the list is not humongous, but it's sizable amount of products. Um, and so, you're encouraged to review the YouTube recording for this video if you're interested in these products, and then, pause the video to study this spreadsheet carefully. Um, I've the top rows that have the Medea and then up until this gradient row right here, these are the saddlebag or straddle the window style heat pumps. And then the products that are below the gradient row, those are box style window heat pumps. Now, this we have one price kind of estimate from a unofficial source of $3,800. And then this one, I've gotten some unofficial numbers that are also in like the 2,800 to $3,000 range. So, um, the straddle style window heat pumps are uh, quite a bit more expensive, but later we'll look at what they're competing against, and which is a ductless heat pump. And I assure you, a ductless heat pump costs more than $4,000 to install. And the performance of these units here, uh, these Medea units up to gradient are they perform down to minus 13 Fahrenheit. So that's right up there with ductless heat pumps. Versus down here, the many of the box style window heat pumps, uh, they have a either an unlisted cutoff temperature where they do list the cutoff temperature. It's like 41 Fahrenheit, and 41 Fahrenheit is nowhere close to minus 13. And you might ask, well, even Portland, Oregon gets colder than 41. So, how am I going to make this work? And the answer is you're this these low cost, like $550 low cost window heat pumps. They do have that limitation, and meaning that, on the coldest days of the year, you will need to have supplemental heat via whatever other heat source you have in your home, because these units won't work on those coldest days. But we'll look at just how many days there are actually below 41 Fahrenheit. And turns out there's in Portland and the Willamette Valley, there's not that many days in the year when it's actually below 40. So there you can get the efficiency gains of using a heat pump versus like electric resistance heat, for example, um, and gain that efficiency, which is like a 2.5 times efficiency gain for the majority of the winter days, which are above 40. So we'll kind of get into that a little bit more. And so here's some pictures of those saddle or straddle style window heat pumps that weigh 129 to 140 pounds, like what it takes to install. Like this is why the manufacturers of there's only currently two manufacturers, I'll just name them, Medea and Gradient, that make this form factor. And both manufacturers are knowing that this is what it takes to install them. They're not currently interested in having consumers buy these things and then take it home and expect them to successfully install it. And so that's why they're currently like sold through HVAC companies, and those HVAC companies get the products through regional wholesalers or distributors. Um, I know that there may be more, but I know that in like the Portland, Oregon, Southwest Washington area, there's a distributor called Gensco. that's going to be the distributor, at least for the Medea unit. I'm not sure who the distributor will be for Gradient. I have not found that out yet. Um, and so with the -13 performance and 100% heat down to 5 Fahrenheit, these are performance specs that are right in line with fairly good quality ductless heat pump equipment and ductless heat pump, uh, one-to-one ductless heat pumps. If you were to pay an HVAC contractor to install one, part and labor total turnkey cost is in the $4,000 to $5,000 range. So, these units are target priced below that. So, um, they're trying to, cut into that ductless heat pump market, not necessarily like, the affordable, very affordable window heat pump market, which we'll look at in a next slide. So, before we maybe dive into some more, one of the things, if you're trying to compare model to model, is alphabet soup. Um, Unfortunately, the industry does not have unified efficiency metrics. That we have quite a few different efficiency metrics, and the top two, SEER and uh, CEER and SEER, and SEER is now gone to version 2, so it's SEER 2. Um, and then there's also EER. So SEER with the C, EER, and SEER with an S. Those are all cooling performance specifications. Um, and so do not try to look at those specs and expect to get an indicator of how the unit will perform in heating mode. These are not heating tests. Um, Now, HSPF is a typical heating season performance metric. So if you want to understand how well a piece of equipment is in terms of efficiency in the heating season, HSPF 2 is a spec that you can use to compare products. Um, COP is another unit that of efficiency that gets make it onto spec sheets. Often they don't, but sometimes they do. But COP is a one specific temperature and one specific operating condition measure of efficiency, whereas um, the above uh, performance metrics attempt to aggregate performance across more temperatures than just one. But the conclusion of this slide is that, if you're comparing product A versus product B, make sure you're comparing across the same metrics. So you're comparing apples to apples instead of comparing product A to B using different metrics where that just cannot be done because then you'd be comparing apples to oranges. And here's a product that has an example that has a fairly comprehensive showing of specifications. You'll find many products that won't have this many numbers shown to you. Um, and so, unfortunately, in those cases, you have to just take a bit of a leap of faith or guess at how the product will perform in metrics that they don't have a test or they didn't list the specification. So above that list of straddle style window heat pumps and box style window heat pumps, if you filter it to the make and models that are available to consumer, this is the filtered list. Um, and some notable ones that come to mind are the ones that are in the boxed red rows. You have units that have a SEER of 14 and 13, and the ones that are 14 are a little bit lower capacity. So if you have a small room, it may be more than enough. I mean, geez, like heating capacity of 7,000, cooling capacity of 8,000, like even the room that I'm in right now, it's fairly large bedroom by my opinion, does not need a cooling or heating capacity greater than those numbers. So, I mean, if you have a 10,000 or 12,000 BTU capacity, like you should probably put a unit like that in like a living room or something like that, not a bedroom. So that's kind of some rough sizing guidance for you. Um, but these units here, they're costing, 550, 650 in that range. That's pretty affordable for a window heat pump. Now, of course, like as I said, they have some caveats. Like these units have a cutoff temperature of about 41 Fahrenheit according to the manufacturer. Um, One of the reasons why for this cutoff temperature being 41 and not lower is because if you think about it, let's say 70 degrees is like, your optimal comforts. Now, if you then add 30 degrees to that, then you're about 100 degrees. In the summertime, typically that's about the hottest days. And if you subtract 30 degrees from 70, you get around 40. So the heat exchanger sizes that's opt like if you design a piece of equipment and you design the outdoor heat exchanger, indoor heat exchanger, if you design them so that they can basically push heat one way or another through a 30 degrees temperature difference between the inside optimal temperature and whatever outdoor temperature is, 30 degrees, then you're going to size those heat exchangers a certain size and configuration. Um, and so these units are, a size for cooling design, and then they just put the reversing valve to be able to then make it work in heating mode. But if you want a piece of equipment to work down to 5 Fahrenheit or minus 13, now you need to have heat exchangers that are much bigger. And so that changes the design quite a bit more. And so, that makes you have to design new form factors, new packaging, new sheet metal cutting, new assembly line, and that all adds a whole lot of cost as opposed to these very, very optimal uh, manufacturing lines that make traditionally just window air conditioners or one-way heat pumps, and that adding that, like I said, about $20 parts, which is the reversing valve to make it be able to reverse and go both ways. But if you're not changing the heat exchanger sizes, then, you know, optimally, you're really going to be able to work down to about 40 um, for that reason. Now, like I said, these are very, very affordable by comparison. Like if we think that the previous straddle style heat pumps are in the 28 or $3,800 range. This is much, much more affordable. And then the other thing is that the weight. If I mentioned before that the weight is like on the other form factors, like 129 or 140 pounds. These ones are 56, 40. This one's you even got one at 44 pounds. These are pretty manageable weights for a consumer to be able to manage this weight themselves. And then all these form factors we're talking about is attempting to also be able to work under a shared circuit 120 volts plug. So again, that also means that you don't have to, hire an electrician to do a special plug. You just plug it in and it should work. Um, so this is a really good option. And later we'll talk about why, like how to find these products in the mix of products that are one-way heat pumps or air conditioning only. One of them is like to look at the heating capacity. If they list the heating capacity that's above 5,000 BTUs, then it's got a reversing valve. They're using heat pump to produce that heat. The reason is because if you do the math on pure electric resistance using 12 amps and 120 volts, you get 1440 watts, and then you convert watts to straight to BTUs. You get about 5,000 BTUs. And so basically, like your space heaters that you buy from the store for 30 to $50, those space heaters only produce on high maximum around 5,000 BTUs. Um, so if you're able to produce 10,000 BTUs, and you happen to use 12 amps, then you're already at a COP of 2 or twice as efficient. But I assure you, these units here do not use 12 amps. They use less than that, so their COP and or efficiency is more closer to like 2.3 or 2.4. Um, Now, again, let's go into the oh well, if these things have a cutoff temperature around 40, then that's what percentage of the winter will it work versus not work? I looked at, for example, Portland, Oregon, took hourly temperature data from the Portland airport from January 1st to 2020 to January 1st to 2025, so 5 years of data, and looked at every hour of hourly outdoor temperature. And here's a histogram of it. Um, about 11% of 11% of the year it's colder than 40, and 66% of the year it's 40 to 65. So it's the number of days or hours when this window heat pump that shuts off at 40 degrees um, will not work, and then therefore you have to turn on your electric baseboard or electric furnace. Um, it's not that much. And so you can displace a lot of electric resistance, heating with just even a window heat pump. So that's very good. So here's some pictures of, what a box style window heat pump looks like installed. And look again, like this picture shows kind of that perfect case where it's displacing electric resistance baseboard heat. So which has a efficiency of 1 versus the box style window heat pump has efficiency of around like 2.3. So, significantly better efficiency. But notice they didn't get rid of that electric resistance baseboard heater. So then on those 11% of the year when it's below 40 and this unit cuts out, then that person can then turn on the electric resistance baseboards to provide the heat. While it's expensive, they're only doing it 11% of the year, so still significant energy savings. Okay, so now we move on to the portable ducted heat pumps. There's a lot more of products on the market in this category. Um, so many that I don't feel like this is a comprehensive list. I think maybe this is at best a 75% list. Um, Now, the notice that the best models on this list have a CER rating of 14.2. Okay, well, and then the worst ones here have a CER rating of like in the 7. Now let's then look at the other category here. Go back here and look at the CER list here. Well, none of them are 7. They're all like, above 12. So, and then recall that originally the list, that last list, the best ones are in the 14 range. Well, if we ignore the 220 to $3,800, straddle style, very expensive ones. And we only look at the ones that are the box style, ones that, you can actually buy. The best performance on this list is about 14. And lo and behold, on this list, the best ones are around 14. So therefore, the best portable ducted heat pumps have a efficiency CER. Um, that's right in line with the efficiency of a box style heat pump. But these ones, as reviewed in the pros and cons of each form factor, these ones you can use for slider windows, casement windows, and you can close the window significantly more than you can with a box style window heat pump. Now, there are ones with very bad efficiency. So again, this is where it's very important that you look at which model to buy and verify that model number. Because, in even the portable ducted heat pump, product category, there's some very bad performers compared to the best performers, double the efficiency on the best ones compared to the worst ones. Um, and the irony is that if you then look at the price column, some of the ones that perform in the 7 point something efficiency range, they're not that much cheaper than the ones that perform at efficiency of 14. So you'd be silly to buy an expensive one that ends up with efficiency of 7 point something. Um, I've highlighted the ones that perform particularly good, and like I said, also the ones that perform the best in this category. They're not too expensive either at like 649, 679, somewhere in that range. And these ones also have a limitation of a cutoff temperature around 40, 41. So again, it's not a full replacement, but they can displace a lot of electric resistance heat in the year if you use one for in heating mode. And here's some pictures of the units installed. Um, we want to highlight that certainly you can DIY a piece of acrylic or plexiglass to use in a casement style window. But I did find this one manufacturer here that makes a turnkey solution. They have instructions on how to measure your window, and they'll custom cut a piece of plexiglass with the correct diameter holes to perfectly fit your model of portable ducted heat pump. They have an extensive list, pretty much covering every model of portable ducted heat pump on the market. And so this acrylic piece, it comes with some weather stripping and some mounts to secure it into a casement window so that you can have a nice clean installation into a casement window like this. Um, these custom cut pieces of acrylic cost just under $200. From my brief look into their websites, um, if you were to, buy a piece of acrylic and then get all the tools to cut it yourself, you might be, including, equipment and labor, and you might be right at $200. So it seems like maybe a reasonable cost. But right out of the box, these portable ducted heat pumps can fit already in a wide range of uh, hung windows and slider windows. As you can see in the right-hand picture, they show, like, for example, this is the model that's the highest performance in that list, um, and it can fit in the window width of 19 to 63. So that covers a really wide range of net-free openings. And then now this is it's a very small category. I only know of one product, but there may be more. Which it's the category of the portable line set to an small outdoor unit heat pump. And so how these units work is that the indoor unit heat exchanger, the indoor fan, and then also the compressor lives in that indoor unit that's on casters. And the only thing that's outdoors is the condenser. So that's why um, the outdoor heat exchanger encased in the box is quite lightweight, at 9.9 kilograms or 22 pounds. That's pretty easy to, lift over a window and put outside. And these units are higher performance. So recall that in all the so-called affordable options we've talked about up to this point, they have a cutoff temperature of 41 Fahrenheit. This one works down to 0 Celsius or 32 Fahrenheit, and still offers very good cooling and heating performance. Um, they are a little bit more expensive, but they sit in that middle ground between, the sub $1,000 box style and portable heat pump and the very expensive uh, saddlebag or straddle style heat pumps that are, getting close to like 28 to $3,800. This one's right in the middle. It's 16. So it also makes sense that, maybe that if the actual heating performance would sit in between 41 and minus 13. And so this one's right in the middle at 32. And so again, this may not be a full turnkey solution for be able to fully replace electric resistance heat. But if you go from 41 down to 32, now you're maybe only got like, 5% of the year in the Willamette Valley that ever gets below 32. So now you're displacing even more um, days when you have to use your electric resistance heaters. And then of course, like if you imagine, all the uh, weather stripping kits that and options for getting a duct to go through a window and still having the window seal properly, um, the hole that you would need to go through is even smaller. Compared to a duct, the line set's even smaller. So the percent of the window that you can close down to is even more, and you gain some of the efficiency on the envelope side there as well. Um, and then price wise, I only have numbers from, Europe's currency, but if you convert it to US dollars, around 1640, and not sure what, like they'll sell for here in the US, but assuming that it's just a direct conversion, then maybe this was the price. So, industry terms, like have said it in the very beginning, these units are unfortunately buried in categories that are listed as air conditioners. And so, even though they have a reversing valve to be a two-way heat pump instead of just a one-way heat pump, they're buried in that category. The straddle style and room box style form factor, Energy Star does maintain a list um, within the room air conditioner web page. And then you have to then scroll down and check this additional feature for heating mode. And then that'll then filter the hundreds of room air conditioners down to just 24 at present that have this reversing valve to be able to go in two-way heat pump. And so that's one way to find them. But Energy Star does not have a list for the portable uh, room air conditioner or room heat pump list. So um, if you want that list, then again, like go back to this list here and pause the video and then study this list. And um, like in this list, if you really want the highest performance model, there's only two. So um, it's a fairly short list at present if you want the highest efficiency model. Um, and then so some industry terms I've said is one is to look at the heating output. If it's more than 5,000 BTUs on the heating output, then it's got a reversing valve because there's no way to be able to do more than 5,000 BTUs, 120 volts shared circuit unless you do a heat pump. Another way to see these units is that they're often listed as 4-in-1 because they can do cooling, heating, and ventilation and dehumidification. So a lot of manufacturers are listing them as a 4-in-1 heat pump or a 4-in-1 comfort or 4-in-1 unit, four modes or something like that. Um, so those are the industry terms. Um, Now, just because, you get a low cost heat pump does not mean that, you magically don't need to maintain it. It doesn't matter whether you have a $4,000 heat pump or a $400 heat pump. You need to maintain those filters. Um, Ductless equipment, regardless of whether it's a ductless heat pump or a portable heat pump or a window heat pump, they all use mesh filters, and those mesh filters are not like your furnace filter, which has all these pleats and to be able to capture the pollutants. It's just one flat mesh filter, so they do need to be cleaned more often. I suggest monthly. Um, and they do need to be deep cleaned eventually. Those mesh filters only filter so much, and there's stuff that gets through it, and you'll need to deep clean it at some point. Um, and if you have an HVAC contractor install a ductless heat pump at, $4,000 or $5,000, those need to be deep cleaned. At $4,000 or $5,000, those uh, professionally installed ductless heat pumps, they're expensive enough that to justify a professional come and do the deep cleaning, and those professionals will generally charge you $300 to $500 for a deep clean. And I also in the weekend do some HVAC work for friends and family, and I assure you, if even charging $300 to $500, you don't make any money on those service calls because they take a significant amount of time to clean, and you have to be very careful to take them apart and put them back together to not break anything. And so that is truly the cost of labor to clean them. Um, Now, if these portable window and a portable heat pump and window heat pumps, that cost 500 to $900. Um, there's no HVAC professional that's interested in working on them, and it's really uneconomical to have a professional do it because if your unit only costs 500 to $900, then how do you justify spending $300 to $500 for a professional to take it apart and clean it? So you're on your own when it comes to doing the deep clean. So I do encourage you to learn how to take it apart, clean it, and reassemble it. Obviously, do it with the unit unplugged. Never do it when if it's plugged in. Don't be stupid. And there are some YouTube videos out there showing people how to take them apart. So, use those as guides. Take a Sharpie and color code the screws. Use an ice cube tray to, keep track of which step, which screws came out of, or, have a friend take a video of you while you take it apart so you can watch the video to know which screw goes back to where, stuff like that. But in terms of cleaning products, you want to find a cleaning product that is, a has the word disinfectant in it, or some mold control is another term. But make sure that it's got not just like cleaning agents, but also disinfectant agents because there are some mold and mildew particles in this. It's not just dust. And so you want to disinfect the evaporator, you want to disinfect the blower wheel, um, and get it clean when the time arises. And you know, the only way around this kind of maintenance is to, get a, full-fledged, ducted central system that has, a traditional pleated filter, which, like I said, is just not feasible for, a lot of people, particularly, renters or in homes with a heat electric baseboard or cadet heaters, or, if you happen to buy a home that doesn't have ducts, installing decks after the fact is very expensive. So um, you don't have to do this, every year. I think that, this kind of level of deep cleaning is needed maybe like every other year. And maybe in your first 2 years of owning a brand new product, you're probably okay, and you only need to clean it on year three. And then after year three, again, it's every other year. That's typically my experience with these products. But your mileage may vary, depending on, how humid your indoor area is, how polluted your indoor area is, how often you run it. There's a lot of the factors. So, you want to, take a flashlight with the unit off, and then lift the louvers and look inside, look at the blower wheel and see the level of dirt buildup, and then make your decision on when to do the deep cleaning. Now, also, I said there is a category that is trying to be a direct competitor to ductless heat pumps. So, we can look at some of the performance of, a fairly good ductless heat pump, maybe not the best, not the worst, but a fairly good one, and compare it with some of the performance specs of these straddle or saddlebag style window heat pumps to see, how they can perform since price-wise it's kind of similar. So we can see like EER, we can compare EER to EER. The ductless heat pump's a little bit better, but they're not hugely better. Um, 11.8 versus 15.4 at 47 degrees. If at a output of 9,000 BTUs, the straddle style is doing a COP of 4. Okay, so now we over here look at 47 degrees and we have a COP of 3.74. So you're like, well, that's worse. But no, it's because it's an output of 12,000 BTUs. So then if it's modulated down to 9,000 BTUs, you can do linear interpolation between this 4.84 number at 3,800 BTUs and this value of 3.74 at 12,000. And it linear interpolate, you might get a value somewhere around 4. So similar. 17 Fahrenheit, 9,000 BTUs, 2.42 COP. Okay, well, this one's at 17. There's a 9,800 BTU output of a COP of 2.71. So, a little bit better at 17. 5 Fahrenheit, 9,000 BTUs, COP of 2. Well, this one, it's got 5 Fahrenheit, okay, an output of 11,500 with a COP of only 1.8. Okay, well, let's see if we can interpolate down to 9,000 BTUs. Well, according to this manufacturer, even if, the COP at 4,000 BT, 4,100 BTUs, it's only 1.72. So, there's no way to interpolate this data to make it get a COP of 2. So I don't know what's going on with this product. Maybe they screwed up on the test, or maybe it really does drop off the cliff once you hit 5. And this straddle style heat pump really is better at 5 Fahrenheit than this ductless heat pump. So as you can see, some parts of the performance curve, maybe the ductless heat pump is better, and maybe the certain other parts of the performance curve, this straddle style heat pump really is better than the ductless heat pump. So, um, hence why they're kind of direct competitors. Um, Look at SEER 2, 18.76, and then over here, SEER 2, 27. Wow, much better. Um, you think, well, is it re like now one thing about these super high Sears ratings is I assure you in real life that there's not that big of a difference between energy of 18 in terms of energy usage between an 18 and a 27. It's not like good luck getting a performance of truly energy efficient of 27 CR2. Like in a laboratory conditions, they you might be achievable, but in real life, like it's closer to 18, I think. Okay, HSPF 2, 10, HSPF 2 at 12.5. Okay, so it's a little bit better. Um, so like I said, the difference is not that huge anymore between the straddle and a style cold climate window heat pumps and a ductless heat pump. Um, and then the other thing I want to share with you is that, uh, you might look online and see, ductless heat pumps sell for something like, in this case, 1350. And you're like, well, this is so much cheaper than, these straddle style heat pumps, which are, 2,800 or $3,800 and stuff. Well, these units, even if the cost is 1350, um, you can't install one of these with just the parts that comes with. You need to buy some additional parts to like wall hung brackets and outdoor disconnects and all that stuff. And then before you know it, you're like probably closer to 1,800 in just parts. And then you need some very specialized tools to install it. And also those specialized tools, you need the skills to be able to use those specialized tools. And that means you're hiring an HVAC professional and they need to spend, close to an entire day to install it. So that's why ductless heat pumps cost $4,000 to $5,000 to in total cost because, the HVAC technician has to, buy this unit. There's some lit overhead office logistics to, cover and to, order it and store it and ship it and transport it to your house and all that. So you add up all those overhead costs and the true hard cost also, and it really does add up to around 4 to 5 grand. Okay, so target customers for these portable and window heat pumps. For the low cost options, I think they're a really great option for homeowners with no central air conditioner and no budget to get central air conditioning and homes with electric resistance heat, whether it be electric resistance baseboard, wall heaters, cadet heaters, electric forced air furnace, and they have no budget to get a ductless heat pump, then being able to displace the electric resistance heat and use the efficiency of these portable and window air heat pumps that are COP of 2.5, somewhere in that range. You're doubling your efficiency or having the cost of your heat. Renters living in homes without air conditioning or without efficient source of heating is another great uh, target customers. You get to, when you move out of your rental unit, take this unit with you and use it in your next rental unit. But another important conclusion to make is that really at the cost of uh, the ones with the reversing valve being not that much more than a straight one-way heat pump. It makes zero sense to buy a one-way heat pump or an AC only portable window a portable or window air conditioner. You really want a portable heat pump or window heat pump because they really don't cost much more than, the one-way option. Now, what's the target customer for some of those like higher cost straddle style um, window heat pumps? Uh, if they are available to consumer, it will be higher income renters who want to fully not use their expensive source of heat. Or homeowners with, again, a home that doesn't have ducts and they don't want to go through the trouble of um, having an HVAC contractor install a ductless heat pump. That's another good target customer. And then right now, those are these straddle style heat pumps. They're being piloted by low-income housing authorities and agencies. And what they're trying to do is basically decommission a boiler system or central uh, plant inside multifamily housing. And so by being able to fully decommission, the expensive source of heat, then they're not having to expend the ongoing maintenance cost of maintaining that central boiler radiator system. And so that's where the savings is coming in to justify installing, a $2,800 to $3,800 straddle style heat pump for every one of those low income housing units. So some conclusions is high efficiency and high performance heat pumps really do exist at every price point. Certainly, there's some caveats to like the sub $1,000 box style window and portable ducted style window heat pumps, um, being the 41-degree cutoff. But a large majority of winter is warmer than 41. So, we're talking still a lot of days when those heat pumps work well and deliver the double or 2.5 times efficiency gain compared to electric resistance heats. Hopefully there's going to be more products on that, midpoint. So the sub $2,000 option being with a cutoff temperature of 32, and maybe there might be products that can maybe even do 17. I would love to have a 17 cutoff temperature around the sub $2,000 price point. But currently there's very few products even globally in this category. So I hope that this category grows. Um, Currently, the sub three or sub $4,000 category gets you those straddle style cold climate heat pumps that perform and in some metrics as good as or even better than some ductless heat pumps. So, they're right in line with competing with ductless heat pumps. Um, and they can be a full replacement because they work down to -13 full replacement. You can fully decommission your electric resistance, heat and not need it at all. And then if you want a even cleaner setup, maybe you want to be able to fully close and lock your window. Well, then you're talking about ductless heat pumps at $4,000 to $5,000 to install one. So like we've covered the entire price point range and what you can do at each price point. And another kind of key point to reiterate is that it makes basically 0 cents to buy a one-way heat pump or an AC only product when it's such a small extra cost to buy one that has a reversing valve to be able to do two-way heat pump and be able to do heat and cool. And then maybe the best ducted uh, and ductless heat pumps that a HVAC professional can install for you will still outperform the best portable and window heat pumps. But like with that straddle style heat pump, the that additional gain is shrinking. And so if you like this presentation and like the work of Solar Oregon is doing in the community, you can support our work and go on Solar Oregon's website or this short URL to donate some small amounts. And we have some additional webinars and in-person events. One is on September 10th. Is it? Oh, look, it's only a few days away. Our We're doing a webinar on how to go solar plus storage. This is like a 101 presentation. So if you have friends or family that are, interested in solar, but they don't really know a lot about solar or batteries and all that, they can attend this webinar and get a 101 course. But if you're a person that already has started in that process and have multiple quotes from multiple solar installers, and you're looking at these quotes, you're like, I don't know, am I comparing apples to apples or comparing apples to oranges? Like, what's going on? The quotes, all these terminologies don't make a lot of sense. September 11th, there's a webinar on comparing solar quotes. Um, One of our big events that we have annually is the Go Zero Home Tour, where we tour a series of homes that have gone through the process of installing solar and electrifying their home, making their envelope more efficient, and hearing the homeowner talk about that process and showing you, their home. And so that's on October 4th from 1 to 5. It's a really great event to, really see firsthand, how it's done and how much it costs and, each person's individual journey. We have some upcoming green energy series. November 1st is a green energy series on cottage clusters, and that uh, de that development form factor is typically very interesting. You have building multiple homes at the same time. Typically, those homes are smaller, and they are typically all electric and with heat pumps and stuff. With smaller homes, the HVAC and the solar and everything is there's some interesting things that you can do with smaller homes and that are built at the same time. Some economies of scale with, maybe solarizing all the homes in the cottage cluster at the same time. So we'll do a webinar kind of talking about um, the interesting things that, our builders are doing in cottage clusters. December 6th, there's a webinar from the Citizens Utility Board on understanding electric rates. Electric rates and have recently, at least in my opinion, gone a little bit crazy. And so, the webinar talking about that. And with that, that's all I have, and I will dive into some Q&A and see if I can toggle the Q&A to come online. Let's see. Q&A, we got quite a few. All right. Question, are there no units for sliding windows? Oh, well, there are plenty of units for sliding windows. Generally the box style form factor is not a good fit. But your portable ducted heat pumps and your portable line set style heat pumps are a good fit for sliding windows. There's another question. Are there state, federal, and Oregon Energy Trust rebates for any of these unique options, such as straddle windows, box-in window, and portable with line set windows? And just to be clear, these are for both heating and cooling. Yes, so these form factors that we're talking about right now are for both heating and cooling. As far as rebates, I'm not 100% sure whether there are or not. I also think that you know, it's one I think that there are like low income programs that are attempting to basically like give one of those like sub $1,000 portable or box style heat pump away to low income qualifying customers for free. But for general consumer, products that are $600, do you really need a rebate for a product that's $600? I don't know. There used to be like $50 rebates for um, dishwashers and refrigerators, and I thought that was kind of silly to offer a $50 rebate because, the effort to process that $50 rebate is more than $50. Any specific rebates for landlords and rentals? I don't know. Explain what a line set is. Help me visualize it. Why does it need more care? So a line set is a typically copper metal tube, and the refrigerant flows inside that tube, and The refrigerant flow is necessary to connect the outdoor heat exchanger, or the heat exchanger that's exchanging heat with the outdoors, with the compressor and the heat exchanger that's exchanging heat with the indoor air. Um, and in a packaged unit that has everything in one box, those refrigerant pipes are inside that box, but you can split the bits and pieces to different packaging and then have a copper line set that um, actually is run in outside the different boxes. Another question is, can the straddle style units be installed in a hole cut in the exterior wall with the same size requirements as the window? Um, I don't see why not, but you would have to basically install that unit, um, and then what's it called? Frame back in the wall, because the way that they're installed, you have to open the window, slide the outdoor unit outside, and then close the window. So if you cut a hole in the wall, you would have to cut a hole big enough to be able to slide the outdoor unit outside, and then like put the wall back together. So. Um, could be done, but it seems like that could be a challenging way to do it. Another question is, are straddle window heat pumps wired into 220? No, they're 120 volts and they can operate on a shared circuit, which is one of the cool things about a lot of the products that we're talking about today is that they're 120 volts and draw low enough amps to be able to work well on a shared circuit. What about cooling in extreme temperatures such as 116 Fahrenheit heat dome here in Portland? Um, so yeah, so these units, either the one-way heat pumps, the AC only products, or these two-way heat pumps, that are they will continue to work, be above and beyond 95 or even 105. The cooling performance will just be less as you go above the maybe design's temperature, but they'll keep working, and you know, having some cooling is better than none. What's the typical wattage at 41 degrees? Um, 7,000 to 8,000 BTU units. Um, I would say for those units, probably around like eight, 8 or 9 amps, something in that range. Um, if you're saying a COP of like, let's say two even, do the math, it's around 8 amps. Is there a way to download these tables? Is a presentation outside of Zoom? Yes, the presentation will be recorded, and then you can then pause the video on YouTube and look at the tables. Are the units designed for side opening windows? Yeah, so the portable ducted heat pumps and the portable line set split heat pumps, those are uh, very good for side opening windows. Installing a window AC. I got a piece of plexiglass from Lowe's shop cut for $40. Yes, I'm sure there are some shops that will do something like that for you. But if you don't live next to a shop like that, then um, you can order one online from that website I showed. Um, and then can the line set model be just installed through a hole in the exterior wall? Um, Unfortunately, those portable line set split models, they come factory charged with refrigerant, and that refrigerant's already running through the line set, and they don't want you to disconnect that line set and reconnect it. And I mean, I'm sure you could. You just need a professional who can do run a refrigerant recovery machine to recover the refrigerant out of that system, disconnect, and then repressure test, re-vacuum the system, and then put the refrigerant back in. And at that point, you haven't saved any money at that point. You might as well, have a professional install like something like a ductless heat pump for you then. When and will the recording be available? Um, It'll probably be like a week from now, and we can if you sign up to the Solar Oregon newsletter, you'll get a email that informs you when the video is online, or you can, check back onto the Solar Oregon YouTube channel in about a week's time to see if the video is available. Um, Yeah, so that's that. If you heat your house with gas furnace, is it economical to get one of these window heat pumps, or is it they're so weak that it's rarely worth purchasing one? Yeah, so if you've got a well-performing central gas furnace, the only way to justify getting these portable window heat pumps is to if you have solar. If you have solar and then you're generating electricity and basically getting that electricity for free, then it would be justifiable. But if you have a fairly efficient central heating system, then and you have a fairly efficient central cooling system, and that the heat and cool delivery is satisfactory to, all the rooms in the house, then there's not really a good justification for these products for that use case. Okay, well, I think I've taken care of all the questions in Q&A, and then the chat is also empty. So with that, I hope you guys have a great rest of your Saturday, and we'll maybe be able to reconnect on a future webinar, or I might be able to see you on the Go Zero home tour. With that, we're going to close out this webinar, and you guys all have a great rest of your Saturday.